NASA's Parker Solar Probe was designed and built at the Johns Hopkins Applied Physics Laboratory to give scientists their closest look ever at the Sun and to help them solve fundamental mysteries about how our star works. And those mysteries can only be solved by swooping Parker Solar Probe very close to the Sun's surface, where it faces incredible heat and radiation like no spacecraft before. To gather this new scientific data, Parker Solar Probe is protected by a special heat shield and equipped with 4 instrument suites. Those instruments gather science data from the solar environment, and then the spacecraft sends it back to Earth. How does it do that? First, we need to understand some Sun basics. The Sun generates a huge magnetic field that spreads throughout the entire solar system. This is what causes activity like sunspots on the Sun's surface. The magnetic field creates what are called magnetic field lines, which are a good way to visualize how the magnetic field, which is invisible, is moving through space. And even though the fields and waves that make up this energy are invisible, they have strength, direction, and other properties that we can measure. The solar wind, composed of charged particles from the Sun, blows constantly away from the Sun, and just like the magnetic field, we can't see it with the naked eye. To measure fields, Parker Solar Probe uses long antennae, just like a car's radio antenna, made of extremely heat-resistant niobium. As the spacecraft flies near the Sun, these antennae pick up small electromagnetic signals as they encounter different waves and fields. Those signals are turned into changes in voltage, which are recorded into solid-state memory, like a flash drive, carried both in the instruments and on the spacecraft. Measuring the charged particles in the solar wind is a little more complex. As Parker Solar Probe flies through the solar wind, particles spinning around these field lines literally smack into special instruments. The speed, direction, and makeup of these particles are recorded as they enter the instrument. Once Parker Solar Probe has finished its solar encounter, it heads back out away from the Sun, now loaded with new data ready for download. How does it get all this valuable information to the scientists? It takes some careful timing and aiming. Parker Solar Probe needs a clear line of sight to send its information back to Earth. That means that the spacecraft's high-gain antenna needs to be able to see the Earth. Having something in the way, like a planet or the Sun, would make transmitting that information impossible. Sometimes Earth is on the other side of the Sun, so Parker Solar Probe will have to wait until it has a clear shot. Once the spacecraft and the Earth line up, it's just a matter of time and RAM before all that data starts to downlink or download at about 200 kilobits per second. But even then, it still has a few more stops to make. The data from Parker Solar Probe will first reach one of the 3 Deep Space Network stations found in California, Spain, and Australia. The stations use clusters of satellite dishes to pick up the data that Parker Solar Probe is sending down. From there, the data heads to the Mission Operations Center at the Johns Hopkins Applied Physics Laboratory in Maryland. Next, it's sent to the Science Operations Centers located across the country and then out to the science team members across the globe. From there, the scientists take the data and use it to better understand not just how our own star works, but also stars throughout the galaxy. And that's how information goes from the Sun to the scientists, all thanks to the Parker Solar Probe.